All right, I'm back. I got a new fancy recording setup. You're actually looking at this through a GoPro. And let's get started. So we already did two buy, sell stock questions. One of them was a situation where you're given a list of prices and you have one buy and one sell. And that was classified as a lead code easy. And we also did another one, which was two transactions, one buy, one sell in that order, and that was classified as a lead code hard. But the two other variations of these questions is unlimited buy sells, which is classified as easy, and then also K transactions, which is classified as a hard. And we're going to be doing both of those today. So let's get started. So for unlimited buy sells, I will call that buy, sell, stock 2. Lead code number 122, if you're trying to follow along. And it basically says, okay, given a list of stock prices, 715364. Calculate the max profit. So previously when we did the buy sell, we just had to keep track of the minimum value we've seen so far, and then really the maximum we see as we go through, and just continually update that. But when we can do K transactions, it makes sense to essentially lock in profits if we know we're going to make a profit. So say right here from this one to, say you bought in at 1 right here, and you knew this 5.3 was coming. Why would you not just like lock in your profit here and not have to hold through this little drop right here? So one idea is anytime there's profit, lock it in. And an even more general version of that is as long as the sequence is increasing, lock in that profit. So the increasing sequences are right here and then here. So it would be 9 and 4. So pretty simple logic. The way I'm going to code it up is just looking at the delta and saying, okay, we'll do a buy sell here if we make profit. See how that would look like in code. See, buy sell stock 2. All right, we get an int array of prices. I'm going to assume valid input at this point. But I'm not going to assume that the length is 0. So in that case, we'll return 0. And we will need to keep track of a min so far of like the current streak that we're dealing with, as well as total profit. So I'll say min so far equals prices at 0, and then also our profit. And then we just have to go to the rest of the array like we said and determine if we should have made a buy and sell. So I through the end of it. So what is our potential profit or loss? Int delta equals prices at I minus prices at I minus 1. So looking at, that would be the 7 to 1 in the example we were talking about. So our cases are if it's positive or if it's 0 or negative. Because in the case of 0, we don't really need to do a buy sell. We would just continue on. So, but if the delta is positive, then we want to lock in that profit. So profit plus equals delta. And then we would want to update the min so far because we did a buy sell. Now that value we just sold at would be our new, essentially, potential next buy, our min so far. So we update that. Okay. What if we have, we're looking at a loss? Well, we don't want to engage in a transaction, but what we will do is update the min. And at the end, we just want to return the profit. So it passes our sample, and it looks like it passes everything. Ooh, I haven't seen these before. I might do these later. So that's buy and sell with unlimited buy-sell transactions. So the next one is K transactions, and I'm going to go back to here. So if you remember from two transactions question, if you're given, I'm just pulling up an example here. Let's see. Yeah. So given a 3, 3, 5, 0, 0, 3, 1, 4. Also, this is buy sell 4, and this is lead code number 188. So this example is for the buy sell for two transactions. So just remember what we did. We came up with two arrays and we said, okay, the max profit starting from the left and the right. So it was 0, 0, 2, 0, 0, 3, 3. Actually, these were 2s. And then 4. Then coming from this way, starting right here, this isn't really 1. Max is 3, 3, 4, 4, and it looks like it stays 4. And then if we add all these up, we just have to find the max. So it looks like it's 6, which would correspond to a 3, 5 buy and a 0, 4 buy sell. So that's how we did that one. And we're going to be using a similar approach for unlimited buy sells. If you remember, so this is a form of dynamic programming because we pre-compute the profit you can make from one side and from the other as well. So let's see how we would do that. So now, given these questions, this is what it might look like. So you'll have your prices. Say that just equals 241. And K equals 2. This means you can make 2 transactions total. Optionally. You don't have to make 2 transactions. This would return 2, of course, because you would buy at 2, sell at 4, making 2. In the case that it was like 3, 2, 1, and you had K equals 2 transactions, your profit would be 0 because you wouldn't make a buy sell. And here's another case that's a little more complicated. 3, 2, 6, 5, 0, 3. And I'm using K equals 2 for a lot of these, but K could be up to or equal really the size of the prices array, but that's essentially half the sizes of the array. One sec, I'm just resetting the... All right, so in this case, if you could make 2 transactions, it would be something like 6 or 7. Let's see here. 26503. Yeah, it'd be a 4 here and a 3 here. So we saw how to do it with 2. How would we do it with 3? Well, in a similar way. And I might mess this up because I'll be honest, I didn't know how to do this right off the bat. But this is somewhat what I'm going for. So this first row will just be our prices. 3, 2, 6, 5, 0, 3. So we'll start with k equals 1, meaning what's the max profit we can make from this with 1 buy sell. And we'll just do this in our head, but I'll show you in a sec how it can apply to multiple, when k equals 2 and so on. We're going to keep track of the buy price as well, which we've called min so far previously. How would that go? So, oh, and also, one key thing about this buy price, we're going to make it negative to essentially factor in any, like if you were to buy at a certain time, that's the amount of profit you would make. How we're going to calculate this, it's just going to be a max function, and it's going to be whatever is greater this, the previous one. So if I'll show you what it's supposed to look like and how to calculate it. They'll be -2, they'll be 2, 0, 0. So this is it's a max function, so it's always going to be the greater between this one and then the negative version of that one. Why? Because this is the buy price. And I'll show you why it's a negative in a sec. But as for this k equals 1 profit line we'll be doing is just the amount of profit we can make at any given point. So it's 0, obviously. 0, yes. We can make 4 at this point. And that's the max we have. So that is the profit with 1 transaction. Let's do it for 2. So for k equals 2, this line will again be our profit, our max profit, and then this buy price, this line is actually kind of the key to understanding this problem, so I'll try and say it a couple of times. This buy price is not just our buy price, it's the buy price factoring in previous profits. Because we already did all the work up here to determine our max profits, we really should just be adding that to our buy price to figure out how much profit we've made so far. So our buy price we're going to calculate similarly. You know, the first one is always going to be the negative of that. And then we'll just continue. Looks like it's going to be -2. And then what about here? Well, it's still going to be -2, I believe. -1, 4, and 4. This buy price, I'm going to actually come up with an equation for it and show you why. So we are still comparing it. So our buy price at any given k, it's going to be the max of either the one to the left or our previous profit minus buy price. Why? What does that mean, Blake? Well, here's what. So we already did the work calculating our profit, right? So why shouldn't our buy price be calculating in any profit that we've already made? So this number right here is actually factoring in any profit we've already made. So you'll see right here, we know we've calculated from this row, we've made a profit of 4 at this point already. And then we're going to subtract the buy price, which is 5 at this point. So if we were to make that profit and then do a buy here, this is how much profit we would have made. So, or this would be, yeah. Or this would be our effective buy price, what we would be making overall. So really this buy price at every single level is going to be factoring in earlier profits. How are we going to calculate the max profit? Well, similarly how we did with k equals 1. So, you know, at 0, we haven't made anything. Still, there's no profits here. But let's see here. We're really trying to just take the max of whatever the price is and our buy price is, and seeing if that's greater or if this one's greater. So I'll draw that. So we're trying to see if what's greater, this value right here, or this plus this. Why this plus this? It's the current price. This is our current floor, what we've bought at. So this would be 4 here. And you can see similarly it would be 4 here as well. 4 here as well. And then when we add these, we actually see 7. And it turns out that 1 is our max profit for 2 transactions. If we had more than 2, we would just keep making more lines, baking in the profit to the buy price, just using the previous profit minus buy price equation, and continue. Now I know I didn't explain that well, so I'll do one more example, and then we'll write some code. So say k equals 2 again. And there's some test cases for k equals higher than 2, but I am too lazy to do too many of these. So let's take this. Let's see. I'm just going to make this example up. 158 29 1. And just from the eyeball test, you can probably say, oh, that's 14. But pretend you don't know that yet. So for k equals 1, our profit line will be 0, 4, 7, 7, 8, 8. And then our buy price is going to be -1. Because it's going to be the negative of this one first for our first value. And then we calculate by that by saying what's greater, this one or the negative of that one. It's still going to be -1, -1, -1. So yeah, so from 1 buy sell with the profit is 8. That's our max profit, which rings true. K equals 2. All right, how do we calculate this? So we had to do our buy line first. And so the first one was just the negative price. And we said, okay. what does buy price equal? Buy equals prev profit minus the buy price. Or this one, whatever one is greater, because we're trying to max profit. So our previous profit here minus the buy price would be -1. Previous profit here, 7, minus the buy price, 8, still -1. Previous profit here minus the buy price would be 5. Previous profit minus the buy price would be -1, but we're going to use 5 because it's a max function. And then previous profit minus buy price would be 7. Previous profit minus the buy price. I think. We'll see if I made a mistake. Now we calculate max profit. So the first one will be, 0 or nothing. And then we'll say, okay, what's greater, this plus this or this value? It looks like it's going to be 4, 7, 7, 14, and then 14. And that's our answer. So our runtime for this, say run and space. Our runtime is going to be O of kn, where k is the number we were given for the amount of buy cells we can do. And because k is less than n over 2, we're going to say this is O of n squared, if that's the way you would like to do it. In terms of space, it's also n squared. And for this first, as I implement it first, I think I'll implement it that. Actually, no, I'll do it the right way. So you could use a giant grid, but there are test cases here where k is 1,000,000. I guess in the thing it can say k is actually can be 10 to the 9th. So that's a huge grid that you don't want in memory. So one insight you can realize is that once you've calculated a row and then a second row, you kind of can throw out these results because you've already baked in the information into this next row because we're building it up, dynamic programming, so that we don't really need this row. So we can really just use O of n space, just 2 n size arrays, and go with it that way. So let's code this up. I'm going to be using the length of the array a lot, so I'll say n equals prices dot length. And what do we got here? So right out the bat, if n equals 0, return 0. So what did we need? We needed our we needed a 2D array, or I guess a 1D array. So we'll say here's our prev array. It'll be of size n, and we'll have our cur array equals new and size n. And this will represent these two, and then we'll just switch these as time goes on. So we need to let's see here. One trick that also works with these two arrays is that if you think about it in terms of k equals 0, if you have 2 0 transactions, literally every value will be zeroed out here because there will be no profit, and you won't be making any buys either. So you can start off with this imaginary array up here being the prev, and this current one being the cur. Again, just 2 arrays that we're using to track our result that we're building up. So how would we do this? Well, we can't make any profit at the first index, so we'll start at 1. I is less than or equal to k. Actually, no, forget what I just said. We're just going to be doing this k times no matter what. And then what did we want? So our buy price at the very first item was always just the negative of the prices at I. So we'll say that here. Int buy price equals negative prices at 0. And then what did we do? Well, first we calculated, I guess, the profit, and then we did the buy price. So say int I equals 1, or j equals 1, j is less than n, j plus plus. Our buy price was, what did we write it down? It was the max of whatever it was there before, so math.max, buy price I minus 1, or I guess just whatever buy price was before, and then also the previous profit minus the buy price. So what is that? So the previous profit was 1 up, so if we were looking at an example here, previous profit, we'd be calculating the previous profit minus the buy price. So really this is the array up, one array up, and to the left. Oh, and then we need to calculate the current as well. So this is our current profit at the certain amount of transactions, whatever we've been doing. Current at j minus 1, buy price plus prices at j. What is that? Well, we're making sure that whatever is greater, this value, one to the left, or basically selling at this value, whatever one is greater. That's what we want to have as the max profit for this level. And then we just reassign these prev and cur things. So, prev equals cur, and then cur equals new int of size n, just zero that all out, and then we have to recalculate cur again. So we'll do that k different times, and at the end we can just return, it will be reassigned to be prev at that point, but just the very last value in this profit array that we're calculating. So let's run that. So it passes for this test case, and it looks like it passes for everything, so I'm actually shocked. It's actually changed from the last time I did it. But you know what, we'll take it. I swear there was a, maybe there's something else. Maybe I'm forgetting it. Whatever. Point is, this is buying, selling stock with unlimited and K transactions. They're good dynamic programming exercises. And hopefully if anyone mentions the word stock in an interview, you are ready to go. So, until next time.